Welcome to the RAYAB program's winter weather diagram. The following diagram examples are only available with the optional analytic module, and the sounding profiles click and drag features require use of the optional photograph and interactive module. We have opened the sample sounding with the standard SKU-T diagram view. To see the winter weather diagram, we use the Displays menu, then select the winter weather option. Note that you can configure RAYAB to automatically open with this diagram by using the Options menu, then select Program Options, and then choose the Winter Weather view, and then close. And the next time you open RAYAB, the winter weather diagram will be initially displayed. Before discussing the two nomograms and table along the left side of the screen, let's modify the sounding diagram scaling to better see demonstrated features. We'll first open the Diagram Options panel with a right-click, select the Pressure and Temperature tab, and drop the upper millibar limit to 600 millibars. Then drop down to the Temperature Scaling section and manually adjust the minimum temperature to a value of -20 degrees. And now over to the Format tab, we'll choose the Ammogram Diagram option, which will enable us to better see the 0-degree isoline. And finally, let's select the Temperature Lines tab and highlight the 0-degree temperature line by checking the Plot Number 1 box, and leave the temperature value set at 0 degrees. Now we can see that our sounding's top level is set at 600 millibars, which gives us a better view of the low-level data. The Ammogram diagram style draws the temperature grid as vertical lines, and the 0-degree temperature line is now drawn in black versus gray. So let's now first look at the thermogram. It's a convenient indicator of sounding layers with respect to the freezing line, where blue shading indicates layers below freezing and red shading indicates layers above freezing. The green line represents the sounding's relative humidity, and for this thermogram the layer examined is 4 kilometers AGL. Since the region of interest is in the lower 2 kilometers, let's right-click the mouse over the thermogram. And now we see the thermogram height selector. So let's adjust the height down to 2 kilometers and then apply it. And now we can better see the two separate layers of warm air. And when we increase the 900 millibar data point into the positive temperatures, we can see how the two warm layers are merged into one large warm layer. And you can also see the relative humidity's green line decrease as we lower the value of the 900 millibars dew point temperature. Okay, let's use the Restore menu option to return the sounding to its original values. Let's now look at the next nomogram, the Precip type or P-type diagram. First, we'll right-click the mouse over the diagram for some additional information. This information explains the precipitation abbreviations used and identifies the Y and X axis coordinate system. And before we demonstrate the Precip nomogram, let's look a little more at the coordinate system, which is comprised of two thickness variables. The Y axis is defined by the 1850 millibar thickness, which is colored in blue, and the X axis is defined as the 850-700 millibar thickness, which is colored in red. And now if you look below the Precip type nomogram, you'll see a corresponding thickness table. And to make nomogram comparisons easier, you can see that the 1850 millibar thickness values are also colored in blue, and the 850-700 millibar thickness values are also colored in red. Okay, now back to the Precip type nomogram. Let's first start by selecting the 900 millibar temperature and modify it. Note that all three diagrams simultaneously change, as does the sounding profile. When we increase the 900 millibar temperature, the increasingly larger warm layer causes the precipitation type to change from a snow-rain mixture to a mostly rain with some snow event, and eventually to an all-rain category. Okay, let's now restore the profile back to its original values. And now, when we move the two warm layer sounding data points into the freezing temperature ranges, we see the snow-rain mixture change to an all-snow event. And now, time to once again restore the sounding. And for the last example, we'll move the 800 millibar data value into the warm temperatures. And when we do, we see the precip type change from the snow-rain mixture into the freezing rain with a trace of sleet category. And that completes the winter weather diagram demonstration. Thank you for watching.